So this week we cover chapter 10, and then next week we have an exam over chapter 6 through 10. But next week I will put an outline up. The take-home portion of the exam will be put up, and it will be due on Sunday, which is the 9th. The in-class portion will be on Friday the 7th.
What do you got next week?
Just like the last. Chapter 10 works with credit cards, savings accounts, mortgage payments. So, I think I started. Yeah, it's recording. Credit cards. Jim charges $125.24, and when the statement comes in January, it shows a minimum due of $20. If he decides to pay $20 a month with a 1.65% periodic rate until July, and then pay it off in July, what will he owe for the last payment? No, a lot of times when you have your credit card, it'll come and say new balance, and it'll also say previous balance. And then it'll say a minimum amount due. And at the usually it's somewhere in the middle, and then it shows all your charges. It will have finance charge, and it will say periodic rate, and then it will say annual percentage rate. The annual percentage rate, this rate is monthly. You just multiply it by 12 to get the annual rate. And that's probably a question I would ask is, if this is the periodic rate, what is the annual rate? And you would just take this and multiply it by 12. If he decides to pay the minimum $20 a month and charge no more till it's paid off, how long will it take to pay it off? Or, well, we know how long it's going to take. I don't know why I put that. How long will it? But anyways, we're going to pay it off in July. When you get a charge on your credit card, your first charge, like if it's paid off and then you charge something, the first month there's no interest. So if you would pay, or he would pay about 125 off, you wouldn't be charged any interest. That's one of the reasons you're not making credit, because you're paying it off. When we credit last Friday, but at least you're not paying interest, so you got to weigh your options. So the $20 would come off of the 125. gonna make a $20 payment. So that means the new balance is $105.24. If we take this minus the 20 plus the interest, which first month, no interest, you get $105. This is the balance then, at the end of this month after you put your payment on. This is what you pay interest on. The remaining balance,
So you minus the 20.
yes. So the 20 was a payment and there was no interest, so we had $105. Now that's what you're gonna pay the interest on then. To find interest, it was $1.65%. So 1.65% of 105 means to multiply as a decimal. And that will tell you the interest for that following month. Round to the nearest cent. So we had this balance, we paid 20, so we want to subtract it, but we were charged $1.74 in interest, so you need to add that. Good, good. $86.98.
I had the 1.74 to.
Yep, you gotta add that in. Because that's the interest that you have.
I had it over there.
This gives you that. So then you take this minus this plus this to get your new balance. So when February's comes, it will say previous balance of $105.24 plus interest of $1.74. So then to find your interest, you take your new balance, 86.98 times the percent. And that should give you 144. Now, if we wanted to pay it off, then we'd pay off the 86.98 plus the interest, and then you wouldn't be charged anymore. But if you don't pay both of that, then you will get charged again. But instead, we're going to make another $20 payment. Now, usually also your minimum payment, as your balance goes down, minimum payment will go down. Any questions so far? So I found the interest from what the balance was. I'm gonna make a $20 payment, and this is what the interest was. So it's this minus the $20 payment plus the interest, $68. Any questions so far? So $68.42 should be left, because we made a $20 payment, but we got charged $1.44 in interest. Getting $1.13 for April's interest. Then you make another $20 payment. So this was our balance, subtract 20 and add the interest. For May's interest, you're getting 82 cents. So go ahead and fill out June and July. For June, did you get a balance of $30.37, which made you increase your interest 50 cents? We're gonna pay it off in July. So 30 minus the 20 plus the 50 cents, 1087. Any questions up through July? In July, notice it's going to be less than $20 because our balance is $10.87 and we're only paying 18 cents in interest. So if we're going to pay it off in July, we would add those two together. $10.87. Sorry, I was reading that one. 11. 5. So if you could not pay it off here, the $30.87, and want one more, then you'll be under your $20, 1105. Car loans are kind of like this. They used to, when you go through the bank and pay it, they print it on a card, but you still could look it up online. And it'll show you each time your interest becomes smaller because you paid off. But it always pays the interest first and then takes the rest off of the loan. And then it'll say during your last payment to find out what the balance is, or it'll mail you a bill first, because it's not going to be the same. It might be close, but it's not always the same. Any questions on that part? So how many months did it take us to pay off the loan? 7. How much interest was paid? How could we find that? Add up the interest. So for the total interest paid, you would just add up your interest. $581. Any questions on the credit card? This is a formula for, well, you can use it for any type of a monthly payment. House payment, if you wanted to see a car payment, if there was a car you're looking at and you find the interest rate, you could find out what the payments would be ahead of time, so you know what you can afford. Payments equals P. P is the principal, it's the amount of the loan. So if you were buying something for $25,000, if the loan was for $25,000, that would be P. If you need to put interest on it, or sales tax, you would put that on first. So sales tax would go on first if there was. If you're paying part of it first, that would come off of it. So P is the amount of the loan, not the amount of what you're purchasing. The annual percentage rate, written as a decimal. And the length of the mortgage in years. So it's the number of years. They put the 12 up there to make it months. Can everyone see the formula, or you have it up? Now, if you remember plugging into the calculator the other day, last week, we were plugging in this, but I already had the numbers there so that you're practicing already. Let's look at this first. A $2,000 home with 3.7% APR, that means annual percentage rate, for 30 years. Now, in this one, we're gonna assume the loan is for 200,000. Oh, it was 3.7. Most loans are either 30 or 15 year. Most home loans. Cars are usually 4, 5, maybe 6. So if we want to find our payments, we just plug those values in here. P is the principal. Now, if you want, you can put the P up on top with this. The rate as a decimal. Plus, you don't have to memorize this on the test, on the in-class test, it will be given.
The formula or everything plugged in?
The formula will be given.
Three times 30, right?
Yep. Or you can put 360. Now, you need to be careful. If you're entering it all at once, this has to be in parentheses. Also, if you're not going to multiply this, it needs to be in parentheses. So you will put it. You can do it in parts. Find this value and multiply it times the 200,000. Find the denominator and then divide them. But keep all the decimal places. I got getting $920.57.
Yeah, I think I put the parentheses in.
Does yours give a fraction bar?
Just put 920 on the six. Or, yeah, if you don't get around. But I had the fraction bar.
Okay, that's fine.
Yeah, I'm gonna put the whole equation in.
Yep, if your calculator will make this fraction bar instead of a division,
Oh.
you don't need that parentheses. I know the TI-84 does it. I don't think TI-83 does, and I don't know about the other one. Everyone getting 920? We want to find our total contributions for the loan. It's your payments times 12 times the number of years. Total contributions means the amount you paid or total that you paid. You take your payments times 12 times the number of years. Because we're paying $920 some every month for 30 years. That will give you the total amount that you paid. Can you buy another house? Pretty close. That's not. Oh, yeah. So at the end of the 30 years, you'll have paid $331,405. They say if you make one extra payment per year, so like when you get your income tax, make a double payment, you can cut 10 years off your loan. So this is what you paid. How much interest was paid? And you can do this if you have a car payment, put your car payment times 12 because it's monthly and however many years of the loan, and you could see how much you're paying at the end. If we take total paid or total contributions and subtract P, the amount of the loan, that'll tell you the amount of interest. So we paid this. The loan was only for 200,000. So we paid $131,405.20 in interest. Now, depending on how high your interest rate is, it can be more than double or triple your house. And right now, I think interest rates are at 5%, between 5 and 6 for a house. Any questions on that? So total contributions is how much you paid, and this is the formula. The interest is just the total paid minus the loan.
So that's like the relative change.
Yeah, because your starting amount, then your total paid, future, yeah, you could do. Any questions? Oops, fine. Okay, a down payment. Deposit $100 per month into an account at 6% monthly rate. So if we couldn't afford or we wanted to put money down on a house or a car, so then we're not paying so much in interest. This is putting money into a savings account or a checking account. We're going to do 6 months. Now, when you put money into your account, interest starts right then. So at the end of the first month, you have interest. Whereas a credit card at the end of the first month, as long as you pay it, you don't have interest. So this one will, savings checking account. Not all checking accounts have interest anymore. You have to see if yours does. Sometimes you need like $3,000 in there to make any interest. But we're assuming we can make 6%. So when you put $100 into an account, at the end of the first period, we will make 6%. At the end of the first month, 6% of $100, $6. So what I usually do is one of these charts will be the take home and one will be in class. So we're going to put $100 a month. So this period is months. First month, second month, third, fourth, fifth. We're putting this in and we made $6. This time though, this isn't something we owe. It's a savings or checking account. It's money we're saving. So we're adding these. In this case, we add all three. So if you're saving money, you're adding it on. If it's something you owed, your payment gets subtracted from what you owed. This is our balance. We get 6% interest, which comes to $12.30. Each month you should get a statement, whether it's in an email or through the mail. It will show previous balance, how much interest you made, and then you decide if you want to put money in the account or not. You can also have it come right from your paycheck. So then we add another $100. So to find the total, it's the 206 plus the 100 plus the interest.
It's still 50.
Say that again?
The dial's
It's
still
55.
It
Yeah.
won't go any lower.
The problem is something doesn't work in here with the thermometer and it keeps running.
That's an old.
My husband works here in the evening, but he's been off for. Shut everything off till air conditioning. But somebody always is complaining that they're cold. I don't, not in my room. I mean, the teacher. But hopefully we can get it cooled down before the exam. Again, just like before, we need to find the interest. So the only thing different is that this money keeps getting added into there. You're building an account instead of paying a balance. The other difference is you make interest on the first cycle. What's nice about a credit card is you don't have to pay interest on the first cycle. So in the third period, how much interest do we have to pay? Anyone? Almost $20, 19.10. Again, we're gonna add the 100. So 318 plus 100 plus the 1910, 437.46. Go ahead and do the last three.
Wait, could you use that formula for this too?
Which formula? The payment?
Time. You could use the formula for this though, right? That specific one.
Yeah, there are formulas. Not, that one won't work though.
Yeah, 'cause it has to be.
12, but also you're putting money into it. If you found the ending balance, I don't know if that would work though. I was thinking if you found the end, if you knew how much you needed in the account, then you could find out what payments you would need to make so that it was there. So if you planned on buying a house at the end of your hopefully college, you could say, I need this amount to put down on my house. If I can find this interest rate, how much money should I put into it? So you could work it backwards and find the payments. 26.25 interest. Put another 100 in. 563.71. Any questions? So in half of a year, how much money is in the account? Well, we know at the end of the sixth period, we have this plus the interest we made in that month. So we'd have to add those together. $739.38. How much was your contribution? How much money did
600, right?
we put in the account? We put 100 here. and then 200, 300, 400, 500, 600. How much was interest?
139.38.
Does everyone agree? How do we find it?
Track your,
Mhm.
you know, your total amount, like the amount you put in.
Yep. Two ways where you can do it. You could subtract these two, the total amount in the account minus what you put in there. Or just add up your interest. Or subtracting is a little quicker. But either way, double check. So to find the interest, you take what's in the account and subtract what you put in there. In 6 months, you made $139 in interest. But you could have also just added this. I like to double check, so I would add those up and make sure. Any questions? Total percentage rate is how much you're making approximately per year when you have a compounded interest. So effective rates take a compounded rate and make it annual. So something was compounded monthly, the effective rate could tell you about what it would be per year. It's used to compare because if I had 6% compounded monthly and 7% compounded quarterly, this is a higher rate, but monthly means I'm getting interest every month. Quarterly, how many times is that in a year? 4. So 7% is only compounded 4 times in a year. So you're making less interest in the year. Well, it's hard to tell which one's better though. Well, if we put them both in their effective rate, then we can compare them. So different percents, different compoundings, you can't compare them. By putting them both into effective rate, we can compare them. The formula, a little bit cut off. Okay. I don't want to use that part though. Okay. So when you have a compounded amount and you want to find the effective rate, this is your formula. Now, depending on different classes, different variables are used. R is always the rate, but some of the compounding, instead of a C, there's an M, and some use an N. But I stuck with your book. And I like C because compounding, it helps you remember what it is. R is your rate as a decimal. C is your compounding, so the number of times again a year. So if we look at the two I wrote there, 6, 10. R is a rate as a decimal. C is the number of times it's compounded in a year. Monthly, there's 12 of them. And then we just plug those in. It will be close to 6%. You should be getting 0.06167778. Now this is R. To make it a percent, you need to multiply by 100. If it said to round the percent 2 decimal places, you need to be careful. You don't round until you make it a percent. Or a percent moves it over 2. So we'd be rounding here. 6.17%. So 6% compounded monthly is approximately 6.17% per year. The other one was 7% compounded quarterly. Go ahead and find the effective rate. Everyone got this, right? Is there any questions? So both of these are the rates per year. But that way then you can compare them. Before, when they're compounded at different amounts, you really can't compare them. Any questions on that? You don't usually see daily and hourly, but we could do that. So we did the 6% compounded monthly. Usually you see monthly, quarterly. Those ones are common. So find 6% compounded daily. What would the C be for daily?
360.
Now, all of these will be close, but so many decimal places apart. But they will all be, if it's 6%, it's going to be 6 points up. On 7. So monthly, daily, it's not too different, but if there's a lot of money in there, that 0.01% makes a difference. Especially if it's money. How would we find hourly? What would C be?
You could do 24 times 365, right?
Uh-huh.
That's 40,000.
365 is the number of days times the number of hours in a day.
It's 8,760. That's our C.
Yep, that'll be C. So if it's compounding per hour, there's 8,760 hours in 1 year. Because we took the number of days times hours in a day, that'll give us the total hours. And we're still doing the 6%. We should have went more decimal places, but that's 146. So rounding 2 decimal places, so they're the same, but if we look, this is 36. This was 31. So if we want 1 more decimal place, or 2 more, they won't know the same. Most accounts are monthly, The reason we went with daily and hourly is so you could see how close it gets to continuously. If something is compounded continuously, the formula is e to the r minus 1. Which will be close to our last answer. Remember, the E is near your natural log button. Now, if you look at these two, we have the 6, 1, 8, 3, 6. Here's where they're different. 3 and the 5. So this is a little faster way down the line, but they're pretty close. So if it's compounded continuously, depends on how many decimal places, but 6.18. Is everyone getting that? The biggest thing when you plug it in, it'll put a caret first. And then it will put a parenthesis. You put your 0.06, close the parenthesis before you subtract 1. Some calculators instead bring you up to the exponent. Make sure you go back down before you subtract 1. Any questions? Any questions on the interest rate problem? Julie wants to buy a home that costs $250. She's going to put down $50,000 and take a loan on the rest. She's trying to decide whether she should take out a 30 or a 15-year loan. She found a 30-year loan at 3.869 APR and a 15-year loan at 3.211. Write a paragraph helping her decide what she should do. Include what the payments would be, the total paid, and how much of its interest. So at one time, well, actually the group assignment will have something similar to this one. We're buying a house for $250,000. We're putting down $50,000. Well, if we're putting down $50,000, how much is our loan? Buying a house for $250,000, but you're going to put $50,000 down. What are you going to owe?
200K.
That would be your fee, your principal, your amount of your loan. We'll do the 30-year loan first. 30-year 3.86. I'll bring the formula. Okay, so there's the formula. This will find payments. So let's find the payments for the third year. This has to be written as a decimal. 0.0386 divided by one minus one plus, same thing. Negative 12 times I just plugged into the formula. $9.39. $9.39. So we'd be paying $939.79. That would be our payments. We want to find the total paid and the amount of interest. Total paid is your payments times 12, because it's monthly, times the number of years, which was 30. Everyone getting that for the payments, the 929? Yes, no? So then the total paid, whoops, I said 929, but it was 939, right? Yeah. The total paid times the number of months, which is 12, always 12, at least for house payment, and then 30 years. So this is the total amount we paid. To find the interest, you subtract your loan. Now this is the total paid on the loan, not the extra 50,000 that's not in here. And we're only subtracting the loan. If you wanted to include the whole cost of the house, then you would have had to add your down payment. Any questions on that? Now, the 15-year loans usually have a lower interest rate. But your payments are usually a lot larger. Go ahead and find the payment. Still the $200,000 loan. Getting 1,400 and some. I'm getting $1,401.55 for the payments. Is that what everyone got? Or are you getting something different? I mean, I could have entered it wrong. I didn't try this problem out. So this is our payments. To find the total we paid on the loan. Take the payments and 12 times the number of years. even though our payments are $1,400, notice we're only paying $252,000 instead of $338,000. So it makes a big difference. If we find the interest, we just subtract what the loan was for. And we're only paying still a lot of money, but we're only paying $52,279. If you can afford a $1,400 house payment. Any questions on that? So a 15-year loan, even though you had the lower interest rate, it's still a pretty big payment, but interest-wise, it's a lot less if you can do it. Any questions? Any questions? Positive. Okay. We will stop there. Make sure you try the homework for next class. The biggest thing is making sure you're able to plug them into your calculator properly. I will give you the formulas on the front test.
Timer, we're saying like, so the next slide will be the paragraph for it.
Yeah. Yeah, so then the next one you could talk about it.
And then I have to do a paragraph to it. I'm gonna,
Yeah.
then after that, put a paragraph. Okay.
All right. Thank you. That would be more good marker and stuff would be. I don't need markers. So this will work for your first set of data. I mean, not for, it'll be the second word, the numerical data. Together, like 800 years worth. That was for the first. All was made up. Right, the age and the year have to be together. Okay. Because those are two numerical. Now qualitative, the first one, it has to be something that's a non-numerical answer. But the problem with names is they're probably almost all a different name.
Yeah, that's
And
why.
so then you have a bunch of little bars, like, yeah, so that won't work. Where, is this all from the same?
Yeah.
I mean, what's the drop?
What department there?
I was just gonna say, I was like,
Yeah,
I
I
like
like
the
the
fun. Right, and so then sporting, maybe there's 5 people, and then shoes, maybe there's 7 people, and so on. Okay. Any other questions on the project or anything? Qualitative data. So someone was doing it as a job, and for qualitative, what the parking is. Quantitative, the second one, it needs to be something numerical. So it could be number line. A week, it could be, on page. But then you also, for the third one, you want something that pairs that are numbers together. So age and years worth, or hours and amount of years worth, something where the both in there. And it has to be 25 different, in this case, people. But it doesn't have to be a questionnaire. It could also be something you research, like during Shark Week, the number of each type of shark that's spotted. That could be the first. And the second one could be the length of the sharks. And the third one could be the length and the weight. And that's something you would just research. Basketball players, football players, any kind of sport, you can find all kinds of data with them. Yards rushing, yards passed. Did you have a question or?
From the formula from like the first few we did in the outline, that reminds me of the last one we did, but it's like a little more layered, the last one is. Like this one, it looks very familiar. Like, up there. It's like, how, what else can we put in?
Okay, that one that we just did, that is the exact same thing.
Okay, good.
Exact same thing.
It's just
I
different.
think I wrote it up there.
Oh,
Yeah, the P time, I usually put the P on top, the formula.
oh, yeah. See the P over here and stuff. Yeah.
I usually put it on top because then I find there's less mistakes. Wondering, but I've never changed mine.
Yeah, I was looking, I was like, I swear we just did this problem.
Yeah, we
Or,
did.
you know,
I just wanted to add to it and compare and have a little bit more practice of it.
oh yeah, I was like, I don't think I'm gonna write this problem, I'm just gonna like, plugging everything in.
Yeah. So it's the exact same.
That's awesome. It's just the P's on top.
Uh-huh.
Okay.
Yeah, I think I should change this, but I always forget when I get home.
I actually turned in my PowerPoint, like,
Yeah, at least a week ago.
oh, you saw it? Yeah.
Yeah, because you were the only one that had.
They got all skewed because people's, all right, so mine was a caffeine, the headache.
Uh-huh.
I thought it was like perfect. It's like I was wanting to see because I get headaches sometimes. I'm a bit of a caffeine addict, I guess. And it started telling me they're getting like 7 headaches, but only having like a dose of caffeine a day.
Then their headaches from something
Yeah,
else.
it's like, so then my headache started getting skewed. I was like, oh man. I just kind of rolled with it.
No, that's okay, because then you just explain that.
Yeah, I was like, so is it cool if we don't have correlation?
That's-
Okay, yeah. I was.
Yeah, no, I think that's fine, because then, yeah, you realize you thought there was gonna be one and there wasn't.
That's exactly what it says. That I originally went in as thinking there'd be a correlation between caffeine and headaches, there wasn't. But
Yeah.
I
No,
was thinking on Reddit for that. People are a little more open. They're a little too open-minded. I need like, I wanted a correlation, but.
well, another thing someone would do then with something like that is the ones where, they're not drinking enough caffeine to see if it causes the headache, they would just throw those out.
Yeah.
But I think it's good that you realize that, so then the next time you do something like that, you know to adjust and maybe ask for people who drink at least 3 cups of coffee a day or something.
If I had a bigger family, I bet I could get more lines of data.
Yep.
I think when you ask strangers,
Yeah, sometimes they're afraid to say, or they want to make it sound good and then they go the opposite way. Is there any questions with those who are online?